Hello, everyone. I'm Samraj. I'm a software engineer on the agent quality team working with Nikhil. All right.
Cool. So our talk is called When Agents Go Rogue. We renamed it last second. I thought this was kind of cute. And how to fix them. All right, we told you this very nerdy talk, creating LLM judges to measure domain-specific agent quality. We're going to talk about that stuff. Oh, that's a cool one.
This is a day of technical difficulties.
That's a cool one. Well, you know what? We're going to learn how to get through it. So I'm not going to read that. So let me tell you who this talk is not for. And you can literally leave if you want to. I will not be insulted. This talk is not for you if you're OK with shipping untested software straight to production. Okay? This talk is not for you if you are OK with the financial and reputational, all the other risk associated when agents really screw up. And if you don't care about agents or AI or any of that stuff that everyone's talking about, you just want to stay in the classical software world, you know, this talk is not really for you either. OK, so everyone seems to be here still. That's awesome. Let's talk quickly about why this problem is very hard. And the problem, of course, is getting these agents to do what we want, making them high quality. They're hard because, you know, these inputs and outputs are full text. They're free form. They're natural language. We often need domain experts to actually help us understand what good quality means. We're always working with a lawyer or a doctor or whoever else in your industry. And we always have this fundamental trade-off between quality and cost and latency. Okay? What we're going to get out of this talk is, one, how you're going to use MLflow tracing to debug an agent. I have to come over here. How to build an evaluation data set with ground truth labels. How you're going to collaborate with a subject matter expert. How we're going to do all of this in MLflow 3. So we're going to show you the MLflow 3 SDK, some of the concepts. All of this stuff is launching soon, Kathy, is that right?
Yes.
Cool.
By 3 p.m.
By 3 p.m. She's the EM. We're going to learn how to evaluate without ground truth labels. And this is a very, very powerful concept here. And we'll explain that soon. And then how you're going to align a custom LLM judge with your interpretation of quality. Okay? So the way we'll do this is we're going to fill out this slide here. Okay? So there are 3 personas. The user, this is the person actually playing with your agent. Maybe it's using your chatbot. We have a developer. Maybe that's you. Maybe that's someone you work with who's building the actual agent. And then you have the subject matter expert, right? If we're a legal firm working on something, that's your lawyer. OK, so the way we'll start this is we'll just slowly add boxes here, and so we can really pay attention to what's going on. In this example, a user is going to ask a question like, what's my bill? It's going to go into this little box, production agent. OK, so that's how this is going to go. We're going to animate these things like this. OK, so to set the stage, we're going to focus on a telecommunications support assistant. We're going to imagine we're a telco company. We're building a chatbot that helps users answer questions like, why is my bill high? What's going on? What's the best iPhone this year? Right? Things like that. It is a multi-agent architecture. That is this year's fancy thing. Every year there's some new thing. I don't know what next year's is. We'll talk about what this means in a second. Actually, we'll talk about it right now. A multi-agent architecture basically says, look, I'm going to have a query like my phone won't connect to Wi-Fi, or my computer crashed yesterday, or just before this. We will have a supervisor agent, just like a supervisor in a company, that will say, hey, report, or hey, tech support agent, you need to answer this subquery, OK? So that's the setup we're working with here. And I'm going to add one more box here, which is MLflow tracing. MLflow tracing will give us the observability into that decision making that we just saw on this previous slide. Okay, so that's the setup. We are also going to show you how you can use user feedback with thumbs up and thumbs down to log them into MLflow traces so we have this nice starting point to find problems. Okay. So with that, I will hand it to Samraj.
All right, demo time. All right. So we're going to go over here into our telco support assistant UI. And I hope this works. OK, nice. I'm going to just ask it a question. You can see here it has the customer loaded in. It's asking me, how can I help you today? And I'm asking, what plan is the customer on? And it's going to go through this architecture that Nikhil just described where the supervisor picks a sub-agent to route to, and that sub-agent is responsible for answering the question. And you can see here that it's gone and answered our question. The customer has 2 active plans, blah, blah, blah. And I can give it a thumbs up, a thumbs down, good or bad. Now this is great. I can see the input, I can see the output. But if something goes wrong, or just in general, if I want to understand what is happening under the hood, I need a way to look at the execution of what's happening step by step. And this is the power of MLflow tracing. I'm going to show you an example right here. Let's go into the Databricks workspace. I'm going to click on experiments, and I'm going to go to our experiment. I'm going to zoom in a little bit here. This is the experiments view. You may have seen this before. This is kind of actually a new UI, and I'm going to go through these tabs as we go through this talk, but I want you to focus on the logs tab right now. And here you can see all the requests that are flowing into my agent. You can actually see the one I just sent right here. As well, you can see like how long it took, when it was sent, and I can see my feedback here as well. User feedback, which corresponds to that thumbs up, thumbs down button. So let's pop into one of these traces. And as I come in, I can see again that input, and I can actually see the flow of the agent here. I can see the supervisor was called. It's routing to a query. If I open this up, I see that it's routed to the account sub-agent. Okay, great. And I can also go into the detailed view, and I can see the same sort of timeline. But this is super, super cool because, again, if something goes wrong in my agent, I can walk through step by step and understand where it went wrong and figure out how to fix it. Let's look at an example where something went wrong. The customer is asking what their monthly plan includes. They want to know their data allowance, blah, blah, blah. And what does the agent respond with? Let me go to this view. Can you please confirm your customer ID so I can proceed? This is a little bit odd. I don't know if you remember there was that customer ID on that UI. And I'm pretty sure I'm already inputting my customer ID. So I'm going to go into the inputs. I'm going to take a look here. And if I scroll down, I can actually see that I am indeed including that customer ID. So something else is going wrong. And now when I want to debug, I can go through step by step. I can go into the router, and I can see, OK, they're asking about data allowance, talk and text limits. But wait, this is being routed to my billing sub-agent. All right, that's a little bit odd. I don't expect that. If I go one level deeper, I can actually see what is being sent to my support agent. And I can see the system prompt here that's basically saying just route it to one of these agents. OK, I know the fix here. It's so easy. All I need to do is specify what each of these agents are, maybe give a couple of examples and what queries should go where, and it'll probably magically fix itself. All right. I'm going to pull up our diff, which I forgot to include here. Let's see. Hopefully this is the one. It is not. Let's say that I've fixed the system prompt. I've included all that information in. And now I want to retest my agent. I'm going to rerun it. Actually, this is the problematic one. But let's say that I've actually gone and fixed it. All right. Just assume here, sorry. Now, should I ship it?
Yeah, I mean, you just replayed that same query. It seems to work. Ship it right to prod.
Ship it right to prod. All right. But the engineer in me is saying, OK, maybe let's wait a minute here. What slide were we on? Slideshow. Sorry, folks. All right, we're here. I have my production agent. I've been looking at the MLflow traces. And now I've fixed my agent in development, and I've shipped it straight to prod. Or wait. Shipping straight to prod maybe isn't the best idea, and I want to draw a couple of parallels here for you. The key point here is that actually GenAI isn't so different from classical software, and if you see this bottom point here, what I've done here is just vibe checked my agent. But if we take the parallel back to classical software, this is like me YOLOing it. And the other parallels here, like telemetry that we have in classical software, which allows us to see, okay, this is what's happening as I'm executing my production grade software, is very similar to what I just showed you with tracing for GenAI. In classical software, we have unit tests, these things that persist around for a long time and make sure we don't regress as we're updating our software. The equivalent in GenAI is evaluations. And I'll get more into that later. But I want you to think, in this scenario, let's say that, I don't know, another bug pops up and my coworker here, Nikhil, just wants to go fix it with a system prompt. I don't really trust him, but he's going to go do it. How do I make sure that he tests the same examples that I tested? He doesn't actually mess up something that I just fixed. Basically, that we're not regressing. And this is the key point about evaluations. This is how we're going to prevent this situation from happening. So I'm going to go back to the flowchart and introduce this new thing, the evaluation data set. It's not really new. You all probably already know about it. The evaluation data set in this scenario is basically a way for us to pluck out traces that resemble or represent individual cases, sort of like unit tests, and persist them so that as we're developing our agent, as we're iterating on it, we're able to run evaluations on that data set and make sure that quality is improving systematically so that we're not regressing. All right, let's take a look at how to do this in Databricks. I'm going to come over here to that same traces view that you've seen before, and I'm actually going to, this time, take a look at what are some of the problematic traces. So I'm going to come over here to my, this is the wrong column. I'm going to come over here to my user feedback column, which represents the thumbs up, thumbs down, and filter on negative feedback. And I can take a look at a couple of these. I can probably see some examples. Maybe, for example, this one is an example, let's see, about this one. The customer is confused about their bill this month. And let's see what the response was. I'll go into the detailed view so I can see it a little easier. If I come down here, oh, that's a little odd. It's a weird robotic error message. Okay. So this is where I would actually go and pick a couple of these examples and pluck them out, add them to my evaluation data set so I can persist these cases. And I can create a data set here. And actually what you'll notice here is that all of this is stored in UC. These data sets are stored backed by Delta, so you get the governance, you get permissions, you get Delta sharing, whatever, all the benefits already built in. I'm going to export to my data set, and I'm going to click on that data set here, and I can see now that the inputs that I had just selected propagate into my data set. And so I have a couple of columns here that I want to explain. I have the inputs column, which all of you already know. The expectations column, which is where I can actually define what I expect my agent's behavior to be like. And I also have the source column, which points to the original trace where I plucked this from. This is some lineage for our data set. Okay. Remember our problem. One of our problems that I demoed here in our agent is that it's actually routing to the wrong sub-agent. I want to go and fix this. How do I fix this? I need to know what the right sub-agent to route to is. So I'm going to add some expectations in here. I'm just going to type something, expected, query category, and I'm going to say, what is this? My customer has 3 kids that they're paying for. They want to know if switching to the family line. All right, maybe this is something about, I don't know, maybe my account. And I could go through and label all of these, but you're probably thinking to yourself, wow, this is a tedious process. Why would I ever want to do this? Maybe I have to, maybe I don't have expertise. And later in this talk, we're going to show you how you can collaborate with subject matter experts to get these labels, or how you can do evaluations without these labels at all. But let's assume that I have these labels. I have my data set all set up. It's time for me to go create some evaluations. So I'm in my notebook here. I'm going to zoom in a little bit for you. And I can see here my inputs. I've loaded my data set in so I can see my inputs. I can see those expectations I just labeled. And I'm going to create this scorer. And I want you to I'm going to gloss over this a little bit. All I want you to take away from this is that it's a way for me to compare what actually happened when the supervisor routed versus what I expected it to happen. It's actual versus expected. And I can run these evaluations on both the agent that I had before I fixed it and the agent that I had after I fixed the system prompt. All right, I'm going to come here. I'm going to zoom out a little bit. And here you can see on the right-hand side that on my data set, I was actually able to systematically ensure that the quality has increased with my change. So you can see that it's improved by 80% on this metric or the score that I just defined. OK, great. Now there's one thing I glossed over here. And just to recap, what we've done is we've gone through the evaluation data set. We've created it, we've added labels, we've developed our agent, and we've iterated on our agent to make sure quality is great. But the thing I glossed over is that I may not always be able to produce these labels, and oftentimes there's a subject matter expert who knows a lot more about the domain than I do. But note that the subject matter expert doesn't really know anything about the agent. So there's these two personas that are clearly distinct. And what I'm going to show you now is the review app, which is a way that I can collaborate with my subject matter expert to collect these labels. It's a fully customizable interface. I'm going to skip straight to it and show you what this looks like. It basically shows the query. It shows this set of prompts on the right-hand side that you can see here that are, again, fully customizable. I can change this to whatever I want it to be. It could be a text input. It could have comments on this. I could select whatever category I want. And I can send this to my subject matter expert to provide me with some labels. OK. So I'm going to pass it back to Nikhil to recap what we talked about and talk a little bit more about some of the syntax that you saw in that notebook.
OK, so this is the slide to take a picture of. We'll give you this slide again multiple times. It's one of those like burn this one into your retina kind of things. But this is the entire life cycle with one missing piece, which I'm going to leave for the end. OK. MLflow 3 is how we actually do this. We kind of hid that a little bit. MLflow 3 is launching, I think, soon. I know I already asked Kathy. MLflow 3 will be launching today, I think. It is redesigned for the Gen AI era. It has all of the stuff that we are used to for MLflow 2 in the classical ML world. We've just added first-class support for Gen AI, so including evaluations and labeling and all this stuff that you need for Gen AI. It is first-class integrated with agent evaluation. That is a thing we launched last year. These are kind of becoming a single cohesive story now. And it is GA, it is production scale, production-grade scalability. Okay? So I already talked about this. That left side is the old world. I work on this, and I always have to Google this syntax. That's how fun it is, let's put it that way. On the right, we've dramatically simplified things. This is just a simpler mental model of how we do stuff. So we're going to just go through this evaluation harness. We call it the eval harness, step by step. So there's 3 arguments: the predict function, the data, and the scores. Your predict function is the agent that you're evaluating. Now, MLflow has all of this really nice first-class support for tracing, OpenAI and LangChain, all of the standard libraries, and you can just kind of put this one-liner. Your traces get sent to MLflow, and we can start evaluating them. You can also use what we call the Fluent APIs, which just means I put decorators, just let me do it. Okay? And not super important, we're just calling off to OpenAI here, but typically you do something more complicated in this function. Okay, so the 2 next pieces that kind of fit together are the evaluation data set, which we talked about already. It's basically an array. It can be a Spark data frame. It can be whatever. Pick your poison. And each row has 2 columns, effectively. Your inputs, that's what we're going to pass to your model, and expectations. And these are what we expect the model to do. This expectations dictionary can be whatever you want. So in this case, we define expected response. We want the model to say this. It may not say it exactly, which we'll get to in a second. But I could do things like expected length, expected tonality, whatever you want, you can stick it in here, okay? So we're unopinionated. And then to use that data, we use what we call scorers. Scorers are just functions that measure what success means to you, right? So a scorer has 4 arguments, and only 4 arguments. The inputs, we already saw that. The outputs of the agent, the full MLflow trace, including all of the internal decision making that we just talked about, and your expectations dictionary. That is optional. We'll talk about that in a second. Inside the scorer, you do whatever you want. Right? You want to call OpenAI, you want to call your own library, want a regular expression, whatever you want. You put that in there. You can return bools, numerics, strings, this complicated thing called an assessment that says, hey, I have a value, but I want to give you a reasoning for that because maybe I called an LLM. You can put that in there too. Okay, so that's a scorer. We're going to talk about 2 flavors of scorers. The first is without expectations. We haven't seen that yet. And without expectations is really nice because it's kind of annoying to write these labels for every single input example, right? And what we can do with that is maybe call a judge, right? So if I want to define a professionalism scorer, I can call our guidelines judge, and I'm using judge and scorer. These are 2 separate concepts. Scorers are those 4 arguments, score a trace. Judges are these just functions that can call an LLM. Our guidelines judge, which is part of Databricks Managed MLflow, lets you do things like the output must be professional in plain English, and it will go and judge whether that output matches that guideline. Okay, so that's without expectations. That's the rest of this talk. With expectations, we just saw that. We showed you a very stupid example with exact equality. In reality, we're going to use LLMs to judge our LLMs because that's what we do these days. Okay, so in this example, we're actually using our correctness judge to take that expected response in the real response and ask, hey, are they, basically the same thing? And we'll use another LLM to do that. It doesn't have to be exact equality, okay? These are the 2 flavors. Okay, run an evaluation. That's how you do it. Putting this all together, now we have these 2 scorers with my data and my predict function. What are you going to get out of this? This is a lot of code I just showed you. You get this nice UI. These are stored in MLflow, and MLflow runs. You will have these forever. You have all the lineage, all of this stuff gets stored in Databricks. It's a really nice process when you are building some production agents. Okay, so that's what you're going to get. The next part, again, we talked about this already. There's 2 things we want to talk about, which is 1, making scorers without expectations. Super powerful. We'll talk about why. And we will also try to make these judges align with us because they're, these are LLMs that do random stuff all the time. How do we get them to do what we want? And so I'll give it back to Samraj to show you. Oh, never mind, I won't. We have some built-in judges. That left-hand side I'm not going to read. We have a bunch of them. And they will catch some very basic stuff, okay? The reality of the situation here, and this is just something to remember, is these will not do it all for you. You must, but you very likely will have to make domain-specific judges because you're in whatever industry you're in, you have specific parlance, you have specific language, you have specific guidelines. It is very likely you will need to do this, and so that's what we're going to talk about, how we actually do that and what the tools MLflow gives us to do that, okay? So now with that, I'll give it to Samraj.
All right, time to go back into the demo. I'm going to go back to one of those examples that we saw before. Let me see if I can find it in this one. I think this is the one I showed you guys. And we're going to take a look at what is going on. Let me actually go here. Okay, let me set a scene for you guys. I've deployed my agent to production, and it's having some issues with answering billing queries. So I'm going to go back into this traces view that you've seen before. I'm going to add a filter on this topic. And I'm not going to get into this too much because there's a separate talk on topics and monitoring. But topics basically are automatically classified for you to help you understand what your production traffic is related to. It helps you slice and dice these assessments and figure out what's going on. And in this case, there's an issue with billing. My user feedback has dropped. I want to take a look at what's going on. And when I open up one of these traces, I can see, okay, the customer is disputing a premium support charge. What does the agent say? This is that same thing I think we already saw before, some weird robotic error message. Okay, I need to go in and fix this issue.
Zoom in on.
And I'm going to take a look at how we can use the guidelines judge to do this. All right. So I've already showed you this process of how we can add stuff into the valuation data set. I'm going to skip past that, and we're going to go straight into our notebook, where I've loaded in an evaluation data set of some of the problematic traces I've picked out. And let me zoom in for you here. You can see the inputs here. And I'm going to define this scorer, which uses the guidelines judge. As Nikhil mentioned, this is a very powerful judge. Lets you define English assertions over any set of inputs. Here I'm saying the assessment should fail if the agent responds with a robotic sounding error message. Okay, I run evaluation. I literally can just scroll down into the notebook and see that same traces UI that we've seen before embedded within our notebook. I can see this query here. Can you break down my charges? Oh, that's a little interesting. This is this is like a slightly different error that I haven't really seen before. And it looks like my assessment here hasn't caught it. Okay, this behavior is clearly not wanted. I don't want it to ask for my customer ID. It already has my customer ID in the inputs. And I can see from the rationale here and understand why my judge is saying it's passed. And I can use this rationale to go down and figure out, okay, how do I tune this judge so that it aligns with my expectations for what this assessment should be? And in this case, I'm just adding an extra assertion that says the agent must not ask for the customer ID if it's already provided in the inputs, which it is. And I pass in the inputs here, and I can see I've gone through this process of iterating. This is the same query, can you break down my charges? And I'll respond with, can you please provide the customer ID? I can actually see here, now it's failing that assessment. Okay, now I want to take a look at how to fix it. I can go into one of these tools and figure out, okay, what's really going on in here? Weird. It's like doing some weird print statement. I don't really know why it's calling a Python execution function, but I know there's a table where I actually have all the billing information that can be used to answer this question about charges. And I'm just going to add this tool into my agent, rerun evaluation, that same flow we showed before, and you can see here that I'm able to actually do the same thing where I'm able to improve quality. If we go into one of these, you can actually see that the response has moved from something that sounds robotic to something that's more, its actual response with my fix. And again, we've systematically checked that quality has improved. Okay, great. I'm going to pass it back to Nikhil to talk about what happens when maybe one of these judges isn't sufficient.
Okay, so thank you, Samraj. The judges we just showed you are what we call pass-fail judges. They're going to give you a pass or a fail, right? That's what a pass-fail judge is. Sometimes that's not enough. Sometimes we want higher resolution than pass-fail. Sometimes we want partial credit because I did something, I improved it a little bit, but like, why do I need to get all the way to a pass here, okay? So we have the full control judge, which is called a custom prompt judge. I'm not going to walk too much into this, but I can basically say, I can use prompt templating here, and I can say, hey, these are the 3 categories that I care about instead of just 2, pass and fail. I'm going to have some partial credit. So like poor recovery means like this is just super robotic. This is the worst. Okay is like, yeah, we got some partial credit. There's some things happening, but it figured out what to do. It's not like max iteration stopping, right? That weird nerdy thing. Or good recovery. So this is like the final, okay, this is good. All right, so we have these 3 categories. You can say, hey, I actually want to interpret these 3 categories as numbers, floating point numbers, and say, look, poor is 0, okay is 0.5, and good, so I have some partial credit. And the reason we do this, by the way, is because LLMs are very good classifiers. They are not very good regressors. That just means that they're not good at generating numbers. They're better at choosing a category. Okay, so that's why we do this type of thing. This is also part of MLflow 3 on Databricks. Okay, the final thing I will talk about to round this picture out is monitoring. And so that's the, I don't know what, I'm colorblind, orange square in the top. These are scores that you can run without expectations, that you can run in the background, you can schedule them, and they will effectively run those scores every once in a while and put those traces, put those assessments or those thumbs up and thumbs down or those numbers directly on those traces for you so that you can slice and dice production traffic and you can understand, hey, are we doing something funky in production? And, oops, go one more slide. What you also get from this is syncing to Delta, so all these traces will flow into Delta for you, and you can build Lakeview dashboards, you can use R dashboarding, you can see the trends over time. So you can sign up for this. There is a talk that Niall was here. Is he here? Yeah, he is. There he is. He's giving the talk tomorrow on monitoring. So please go check that out. So again, this is the slide to take away. This is the full workflow with monitoring and evaluation datasets and subject matter experts that we are launching with MLflow 3. Super exciting. I'll let you take your pictures. We're gonna have time for. Okay. Let's talk about the future. What we just showed you is kind of a lot of work. Let's just be honest with ourselves. I had to make this judge and go get this subject matter. Oh my God, it's all this stuff. Now, the reality is you have to do that. Like Gen AI is hard. You have to do that in today's era. We do think that we can make this easier. We are in the era of AI, so why can't AI do this for us? Like AI agents for our AI agents? So what we are working on, this is kind of cool, is what we call automatic insight, name TBD, automatic insights, where agents debug agents. So you can go and ask questions like, why is my agent erroring? It will go read all those traces and try to find that pattern for you by using all the judge rationales, using the human feedback, reading the traces, reading the error messages, all that, and it will just give you some English language that says, hey, maybe it's this thing. And so I actually injected a bug in one of our agents and said, hey, can we go find that bug? I didn't tell the agent what it was. And I just threw an exception when, this is Samraj, I called the tool Samraj. Once in a while I call that tool and it throws an exception. Okay, so why is my agent erroring? It will go and just do all the pattern matching and figure out that, hey, it's the Samraj tool that's throwing an error. And if we have your code, we can actually show you and point you to that, like if you're using agent framework, right? And then we'll show you some example traces of this. So this is way reducing the time to actually understanding what's going on. So this is something we're working on. Reach out to us if you're interested in this, or come talk to us after. That's doubled. And that is the end of our talk. We have an email here. You can reach out to us you can find us after this talk. I think we have time for questions, which is amazing.